This conference will now be recorded.
So we are discussing about exception handling, right?
Yes.
So we have gone all these things. What's an exception and all, right?
Mm,
And
mm.
I said to handle an exception, you just write like this. I have not given you an example of arithmetic exception, and I have not written, right?
Mm,
No, I have not started
okay.
arithmetic.
Yeah. Yes. I don't think so. Yeah.
Yes, I wasn't. So you will have different kinds of exceptions. So you handle that exception by writing your try and catch, right? And so even I think I showed you the slide. So for example, whenever there is an exception comes, what happens? It will ignore the rest of your try block and it will execute the catch block. And if there is no exception, it will ignore the catch block. So you handle exception by writing try and catch. So we'll see what is a try and what is an exception. So you don't have any doubts in the previous session, right, Mike?
No.
Assume that you have a method called divide. I'll write that method in. And I'm taking a number, something like int a equals to some 10 and int b equals to some 2, right? And what I'm doing, I'm just printing that I'm having a c variable int c equals to a divided by b. I'm doing, right? I'm printing that c value. I'm just performing a division operation. And this is a common example. I'm just printing here after c, something like after division, something I'm printing like this, right? So if I run this, it will be a normal execution, right? So there
Mm,
is no exception. So it will print you the values.
5.
So the value 5, and it will say
Mm,
after it, there is
yeah.
no exception,
Yes.
right? So for example, instead of 2, if I'm trying to divide something by 0, right? So what happens now? What is this? If I'm running this program, what will happen? Mike, can you tell me? So instead of
Uh,
dividing two, I'm just right now I'm dividing by 0.
so exception, I think.
Yes, exactly, exception, because
Mm.
something divided by 0, what is nothing but
So
infinity.
it's yeah, it's wrong.
It's infinity, right? So a
Mm.
way see, I cannot hold infinity value, right? So it will not execute the remaining part of the code. So where your exception is coming at the 8th line, right? So that's you can exception. Some disturbance,
Yeah.
there is a
Uh,
disturbance.
your sorry, your voice was like very it's very like lower. I don't know.
Okay, it was high only volume.
No, no, now it's fine. Now I don't know. Your voice was like far away for just for like temporary. Now it's like back.
Okay, okay. Please let me know when you face some
Sure,
issues.
sure, sure. Mm.
I don't know. Sometimes it is good. Sometimes it is. You're saying it
Yeah, yeah.
right. Even I was connected with the 5G fine. Okay. If you see, you are getting some exception here, right? So what is this exception? That is nothing but your arithmetic exception. This is a exception designed by Java people. Since if any number divided by 0, something number. So whenever you do a real-time applications, you get there is a chance of getting an arithmetic exception because you just hard coded it. But when you do a big calculations or something, you not hard code it, right? So there is an application where you do some divisions also. So in whenever in runtime, you can get this arithmetic exception. And remember that there is an exception that will always come in the runtime. There is no exception that comes in the compile time. So every exception comes at runtime only. And you can see the exception is came at the exception, and it was there where the exception has been came. So you can see the exception has been came at the line number 8, right? And you can see this after division code was not executed, right? So it
Mm.
means nothing but improper termination, right? You are not handling this exception. So you don't want this to happen. So whenever you write a bulky of code, 100 lines of the code, every part of the code should be executed. At some, for example, there is some exception at some part of the code, and if you are not handling it and the remaining code is not executing, so that is not a good significances, right? So every part of the code has to be executed. So then you need to handle that exception. How you handle it, that exception is nothing but by writing try and catch. So what I need to do, so I just want this after division. I just want the normal termination. I don't want abnormal termination. This is nothing but your abnormal termination. And try, if I write a try, immediately I should follow it with a catch. So try and catch. And what I'll be writing here in this catch, I'll be writing that. So here you can write a message, something like do not divide by 0, something like that you can write. Okay. C cannot be resolved to a variable because it has been. So this is a place. So it is a Isha. Give me a minute. Give me a minute.
Yes.
This is nothing but writing try and catch is nothing but handling your exception. Handling an exception means obviously the exception will get. But here what you are trying to know, you are trying to handle it and you are trying to execute the complete code. So it means it will execute your after division also. So I'm just writing. Do not divide some message you are just writing. Now you will not get this arithmetic exception because you are handling that exception. So you can see do not divide by 0 and after division. So now exception has been, there is an exception has occurred, but you cannot see that message because you are not printing. So for example, in the catch block itself, I can print that message. So whenever you want to print that message, I can print that X. So this is the name, a variable where it will hold that exception, or I can call print stack trace. So you can see arithmetic exception divided by so this is what happened and that is what you are printing, and you want to print the clear information, you can call print stack trace. So that is a method that is present in your exception, which will show you what is the error and from where it has been called, everything will be printed over here. So when I call print stack trace, so if you see do not divide by 0, it's your catch block is executing and what it is getting printed, and it is printing your so what it is printing, even it is printing your do not arithmetic division and from where it has been called. So this is the place from where it has been got that exception. This is the line it got that exception. So everything was printed. So this is nothing but you are handling that exception, right? If I write with try and catch, that is nothing but my handling of an exception. Here for how it will happen. So whenever you get an exception, what happens? The exception objects will be created. So who is responsible of creating your exception object is nothing but the method where the exception got occurred. So for example, the exception got occurred in the main method. So in the main method, the exception object will be created, and that exception object will be thrown to JVM, and JVM by reading that exception object. So what the data will be present in that exception object, where the exception has occurred, and what is the method name, what is the class name, and what is the line number the exception has been occurred. So it will just be thrown to JVM, and JVM will read that. Java virtual machine will read that exception object, and it will come to the particular line, and it will see whether the code was handled or not. If it has handled properly, if there is a try and catch, so it will execute normally. There is no abnormal termination. What is the meaning of abnormal termination? It will not execute the remaining part of the code. That is nothing but my abnormal termination. So your abnormal termination will not happen whenever there is a try and catch block, and it will execute the remaining. For example, if there is no try and catch block, what it will do, it will call the default exception handler, and it will print the print stack trace, and there will be an abnormal termination. In case of abnormal termination, the code will not execute top to bottom, and you will get something like do not divide by. So you know you will get you will not get this after division. So whatever the lines after that I wrote will not be printed. So that is nothing but my abnormal. Here what happened? 10th line there is an exception. As soon as you get an exception, it comes to the catch block, and it will be printing this, and again it will come out of the catch block and it will print the remaining statement. But if there is no exception, your catch block will not execute if there is no print state stack trace. So I can just write to make sure that inside catch block. So I'm right, assume that I'm do not divide by 0, I'm writing it inside catch block, right? So assume that I'm dividing something by 2 again. So now your catch block will not be executed, right? Because there is no exception. You're not dividing by 0. You can see the catch block has not been executed. I return do not divide by 0. So there is no track this. So there is no exception. But it is like, so in real-time application, you'll not hard code it, right? So you may enter the value, or you may, when you do some calculations and you get this value. I think I've told you scanner class, Mike. I've told you scanner class. What is
I scan. I don't think so. Or
okay.
maybe I forgot.
Okay, fine. So you have a scanner class. So what is the purpose of the scanner class is nothing but it's a predefined class which is used to read the data from the keyboard. So in C you have printf scanf statement. So as of now I'm hard coding the A and B values, right? So instead of hard coding this A and B values, I just want the user to enter these values. So then I'll be using a scanner class, a predefined class that is present in util package. So and what is the input that I will be giving is nothing but system.in. So what is the system.in is nothing but how you have system.out.println. So system is a class and dot in is a reference variable. So you are entering it from the keyboard, right? So that will return you the input stream object. So you can see when I have just came over here, you can see that what is the return type of this. You can see that is an input stream. The standard inputs, the stream is already open and ready to supply input data, typically keyboard or another input device. So you can see this is an input data. So it is to read the input from the keyboard or something. So what system dot will return? System dot in will return. It will be returning you the input stream object. What system dot out will return? It will return me the print writer object. So that's the reason you are. So if you see system dot out dot println, the same thing. So your system is a class here. Here out is a reference variable. Okay, it is opening a dot class file. I'll just see from here itself. You can open the .java file and see that. So I'll just see. So your system is a class and dot in and dot out are the reference variables. They are nothing but your static variables. So how you call your static variable? By the class name, right? So these variables will
Yeah.
You are sleepy.
Yeah.
So
Yeah, I drink a coffee, so it's fine.
so is it clear up to this or any confusion?
Yeah. So, one question: what is the EX? What is
Yes.
EX?
Where is the? It's a variable, a reference variable. Arithmetic exception. You're getting an arithmetic exception, right? So hold that exception. You have a variable which will hold that exception. You can write EX or anything. It's like some.
Okay. Okay.
Right here, I can write here.
Okay.
So
Okay.
the variable which will hold that what exception you got. That's it. The detail. You can print that E, right? So when I print that E, you can see what it is printing. It's printing that whatever the exception that you get.
Yeah.
That your exception, right?
Yes.
That's
And yes. And so and okay. And the scanner is basically to when you type in something, you want to type, you want to input something into the system, right?
Yes. So we generally hard coded EAB values, right? So instead of that, I'll enter it from the keyboard. I'll ask the user to enter the values.
Yes. Like enter when you want to enter something in a keyboard.
Yes. So I've used a scanner class, and I'll pass a constructor called system.in because I just want to input from the keyboard, right? And if you see here, so for example, whenever you want to input from the keyboard, you may input the different kinds of values. For example, you may input the string values, you may input the float values, or you may enter integer. So for that, you have a different kinds of methods. For example, if you are trying to input a int value, I'll have a method called nextInt. So if you see, has a method called next. So next will is the method I need to use whenever I need to when I am inputting a string. So for different types of inputs, I have different kinds of methods. So whenever I have a next int, I am going to it will read the int data. So whenever you input a string int value, not 1, 2, 3 integer value, you use a method called next int. So I'll be storing it in a variable called a. Right? So similarly, so I'll just ask the user just to enter the numbers before this. So system.out.println, and I'm just asking the users to enter the numbers. And b equals to sc dot nextInt. Right? So the a and b values, I'm asking just the user to enter that. If the user is entering the 0, then you get an exception. If the user is not entered 0, you will not get an exception. Before case, I have hard coded it. In this case, I just asking the user to enter the values. So you can see it is just asking me just to enter the number. So a and b. So what is the, I just want to enter? I just want to enter something a as 10 and b as 2. So there is no exception. So I'll enter the numbers something 10 and something 0. So you get an exception. Right? So this is nothing but very arithmetic exception by 0. Whatever is getting printed, that's it. So when you print stack trace, it is going to tell you the where the exception has occurred. So what is the line number that is will be there in your stack trace. For example, it may called from different methods. So this method may be called from you may you are right now we are using an await method. Generally in application you use it from different methods. So every stack trace it will print. I'll show it more clearly. So but when you print only the e reference variable, it will be printing only the what is that exception? It will print only that arithmetic exception divided by 0. So the reason you got an exception, that is what it is going to show you. Is this things are clear, right, Mike?
Yes, yes.
So you can see that's what if there is an exception, what happens. So you can see whenever there is an exception, your rest of the try block will be skipped actually. So for example, you get an exception at the 14th line, right? And the rest of the try block will be skipped. It will not execute. After division in try I am writing. So this part of code will not be.
Sorry, Suya. I just go to get water, like
Yes,
to,
yes,
to refresh.
yes.
And yeah, sorry.
Take your time.
Hello? Hello?
Mike, even I went
Hi,
for
yes,
graph.
yes, I'm back. Yeah, I'm back.
Even I
I
went for
just,
graph.
yeah, I have, okay, I see, another question. So the asymmetric exception is also like designed by you, right? I can write a different, like, I mean, for the cache, line 18, the asymmetric exception is also you defined, right? Because like, for example, I can write different things, right?
Actually, arithmetic exception is a predefined one actually. So
I
you
mean,
have a user-defined exception.
I mean here, if I write this like handling try catch to handle handle the exception, I mean my point is I have to write a how to pronounce asymmetric exception. I need to write this one exactly, or it depends. I can write, for example, like exception only. Yeah, that's my question.
Yes, you can write exception also. You can write arithmetic. I am not.
Okay.
So your exception is a parent of everything. But you cannot write something like null pointer exception where there is no relationship between your arithmetic exception and an exception. So why you are writing an arithmetic exception here? Because there is a chance of getting an arithmetic exception, right? So when you divide by 0, you know there is a chance of getting an arithmetic exception. So you are not guaranteed that you get an arithmetic exception. So you can write with an exception also. Your exception is a parent which will hold your arithmetic exception. So your exception or arithmetic exception, this was given by your Java people itself, right? So even I can write exception also here. That is not a problem.
Okay.
Your parent can hold the child. So I'll show the hierarchy. What is that? So if you see, this is an exception which is of parent of your arithmetic exception as well as your so this is an exception which is parent of your arithmetic exception, and there are many exceptions. So that's the reason you can write, if there is an arithmetic exception, you can hold with arithmetic exception also because it's a parent, right? So we'll see that what is it, except what is the parent hierarchy, and I'll be telling you even. So now if I run also, it will be the same. So, but what happens if I'm just getting an exception here, your after division try will not execute. So whenever I get an exception, immediately it comes to the catch block. So enter two numbers, I'm just entering something 0. So you can see there is no after division that has not been executed. After division in try. So that is after do not divide by 0 is what.
I got to a point. Yes, basically, if everything is okay, the try catch will be ignored, right?
Catch will be ignored.
Catch. Oh yes, catch will be ignored. But if there is something wrong, the catch will catch it. And
Yes.
the rest of the logic rest of the code will not be executed.
Yes. So for example, if there is an exception, what happens? Immediately it will come to the catch block. The part that is present in the try block will not execute. Assume if there is an exception, and it will execute the catch block and it will execute the remaining code. When you are writing a try block, a try and catch, it is nothing but you are handling an exception, right? Assume that there is a case you don't get any exception. There is not, you are not dividing by 0. What happens? It will execute this. It will execute this statement. It will execute. If there is no exception, nothing happens. So it will come to the 16th line. After that, there is no exception, right? So it will not go to the catch block. It will execute this part. Is I'm clear, Mike?
Yeah.
Okay. So here you see there is a chances of missing some part of the code. So for example, you get an exception. What happens if you handle also some part of the code were not executed here, right? And you have so some part of the catch block code is not executed, right? And assume that if you didn't wrote try and catch, the sum of the code is not executed, right? So in an application, when you do, there are a lot of missing of some code, but what you want some part of the code to be executed guarantee, whether you handle the exception, you don't handle the exception, if you get an exception or you don't get an exception, I just want some part of the code to be executed. So that part of the code, I'll be writing it in a finally block. For example, you do some DB connections and you just for example, you just want to close the DB connection, which I just want to be executed. So there are some part of the codes that you write it in a finally block. So I'm just writing inside finally block. So this part of the code will be executed mandatory. So this is nothing but your try and catch, and finally you need to write try catch followed by finally, and finally cannot be written alone, right?
So basically, finally must be it doesn't matter you have an exception or not. Finally will be executed, right? That's your point.
Yes. Whatever the case, your finally will be executed.
Okay, I see.
If I get an exception, or
it's like something to make sure. It's like something to make sure this line of this line of code will not be missed, right?
Yes. So you got an exception inside finally. You didn't got an exception.
No, we don't get. It's right? It's not a 0. Like the pair. I mean, after division and the try. Inside after the.
It has not been executed the catch block, but you see the finally block executed when you don't get an exception also. This is like mandatory code. So here what you are doing, you are handling the exception.
Please give me one moment. I just check. So after division in try, okay, 5 after division in try, and then inside the finally block, and it skip the catch part, right?
Yes. I just send it. Just see it once again. Do you have any doubts? Let me know.
So because there is no exception occurred, so that's why it skip the catch part, the catch block. Okay, yeah, that's fine. I just want to like go through by myself to make sure the logic is right.
Is it fine, right?
Yes, it's right. It's correct. It's right. And the print stack trace is like a built-in Java method, right?
So whenever you mark something, it will show you the solution. So it is a method from print throwable class. So this
It's
is
like a built-in, like a Java built-in thing, right? It's
yes,
bundled
this
with
is
Java.
a predefined method. So it will show.
Predefined. Sorry. Yeah. That's a better word. Yes, predefined. Yeah.
So from where that is method is there, that is present in land package,
Mm.
and throwable is a class. Inside that throwable, you have print stack trace method. So your exception is the child of throwable class, right?
Mm.
So your child can access the parent method, right? So that is the reason it can access the print stack trace.
Mm.
You got how it is accessing print stack trace method. So
Yes. I got it. Yeah.
throwable is nothing but the child. Sorry, throwable is the parent of exception. You have an object that is parent of everyone, right? So you have an exception that is a child of throwable, right? In this throwable, you have a
Throwable is a class? No,
yes, throwable is a class. It's a class. Throwable is a class.
it's a class. Okay. It's a class. Okay.
Right?
But they are like general speaking, they are. So I noticed there is a huge huge amount of exceptions, right, in Java.
Yes. There are a lot of exceptions. We'll see that. So I will not be discussing all the exceptions, but I'll be discussing the most of the exceptions.
Sure.
Yes.
Just for curious, even for you, Suya, you encounter you encounter some like exception like in your experience, right? But not all of them. Like even for you, because you have many years of experience.
Yes. The most of the common experience that we face in your applications is nothing but a class not found exceptions, null pointer exceptions, sometimes a stack exceptions. You face a lot of exceptions. So in your real-time application, exception is a huge topic actually. So every time when you
It's
get a
like
new,
it's very vast. It's like a word.
it's very vast. So, but you can debug it. You can see it in net and see what is the reason of that exception. So I'll be discussing most popular exceptions that are common in an application.
Yeah, sure. Yeah, just I'm asking because I'm curious about about
Yes.
this about Java, because I don't know how big it is. In what kind of scale the Java can bring us. So that's why.
Yes. There are a lot of things actually. You can go and.
But I think for common use, I don't think for me I will even encounter less than you, because for me it's just for testing purpose.
Yes.
I use because as a developer you will use much more, I think.
Okay. So, but even when you can learn more and you can also do things.
Yeah. That's true. Yeah.
It is not
I agree. Yeah, I agree with that. Yes, yeah, because you understand more, then it will be easy for you.
yes.
Yeah.
Right. So here, before in this case, what we are doing, we are executing this, and we are having a catch block, right? It means we are handling an exception, right? So we will write a code without handling an exception also. So if I write a finally block without this catch block, so that it means I'm not handling it.
Yeah.
Right? So in this case, I'm not handling the exception. So it means you get an exception. So what happens? It will not execute this, and it will not execute after division also. But when you are not handling also, what is the code that it will execute inside final is a mandatory thing that will execute. So you can write try catch finally, or you can write try finally. So when you're writing try catch finally, it means you're handling an exception. It means the program will not terminate abnormally. Everything gets executed if you are writing a catch block. If I'm writing a try and finally, it means that you are writing some code in the finally that will execute, but you are not handling an exception. If I'm not handling an exception, it will not execute after division. It means it is abnormal termination. Everything in the code was not executed, right? So if I say run as Java application, you can see enter the numbers. So I'm just entering something 10, 0. You see only it executed inside finally. You cannot see after division line got executed. It means there is an abnormal termination. When you have an abnormal termination also, your finally block is mandatory to be executed. So you may have like when you get this question like what is a finally block and when it will not execute. There is only one thing that will not execute when you just system.exist. So forcefully you make the programmer to come out of that. In that case only your finally block will not execute. In other cases your finally block will get executed. You got this right?
Yeah. I got to the point.
So you can see this slide makes it more clear, I think. So when there is no exception, what happens? Your try block will execute and your catch block will not execute when there is no exception, and your finally block execute and we next block the code. But if there is an exception, for example, it has raised in this line. So that from that particular line, it rises to the catch block. We'll ignore the rest of the try block, right? And will execute the catch block and it will continue with the final block. Right? I think this diagram should make you more clear the topic. Is it fine, right?
Yeah.
Okay. So generally you have an object that is a parent of throwable, and throwable has two subclasses like exception and error. So we'll see more about errors, but error is something you cannot expect it and you cannot handle it. So handling in the sense, for example, you get something stack overflow exception, stack overflow error, or memory out of bound memory error. So what is this out of bound memory error? Is nothing but whenever your heap area is full, right? When you are trying to, whenever you create an object, the object will get created in a heap area, and whenever your heap area is full, you may get a error like a stack overflow error. Sorry, not stack overflow, out of bound memory error. So that kind of error you cannot predict it and you cannot write try and catch, right? So it is how your compiler will also not have the knowledge on that. So whenever you just try to do some increase in the heap area, you do some other activities. So that is nothing but your error. I'm not talking about compiler error. Compiler error is different. So your exceptions can be checked exceptions and unchecked exceptions. I'll tell you now. We'll discuss what is checked exceptions, what is unchecked exceptions. But before that, you can see this is the hierarchy of an exception. So you have an object and you have an exception class. Here you have an IO exception, class not exception, class not found. We'll see some of this. And you have runtime exceptions, this arithmetic exception, class exception. I'll call all this as nothing but my runtime exceptions. So exceptions are generally classified into two types, Mike. One is checked exception and one is unchecked exceptions. Or I can call checked also compile time exception, unchecked also I can call that as runtime exception. Unchecked exception, if there is an unchecked exception, I'll call it as runtime exception, or I can call it as unchecked exception. If for compile time exception or checked exception, both are same. So what is this checked and what is this compile, runtime and unchecked? So why I'm calling this? So for example, as I told in the beginning of your class, your exception will never come in the compile time, right? As I told, for example, when you want to write money from the bank, you get some errors. So exception that you get in at runtime only, right? So even this arithmetic compile time, so this divide by zero, where you are getting, when you run the program itself, you are getting, right? If you write here zero also, it is not showing any compiler error. So the exception will never be it will be in compile time. It will always be at runtime. But why you're calling it as checked exception? I'll tell you. I'll just make that clarity within few minutes. So for example, here if I'm trying to divide by zero, assume that I'm hard coding it with zero, right? In this case, when I'm trying to divide by zero also, whether your compiler is showing me any error, Mike?
No,
it is.
No, there is no error.
There is no error, right? It means here when you don't handle also, your compiler is not showing any error. So here there is no, your compiler is not checking that, right? You are allowed to get, you are allowed to compile and it is fine. So that's the reason this is nothing but your arithmetic exceptions are nothing but unchecked exceptions, are they are nothing but they have named it as runtime exceptions. Your compiler will not bother, it will not check that itself. So when you, if you handle it, what happens? Okay, it's fine. You write try and catch, your program normally executes. If you don't handle, it will not execute, but you will not get compile time error. And that's the reason you call them as an unchecked exception or runtime exceptions. If you see, you can see there are unchecked. Your arithmetic exceptions are class not all these are nothing but your uh, unchecked exceptions, or I can say that are nothing but my runtime exceptions. Your compiler will not show any error for that, right? And you have some exceptions that are nothing but your checked exceptions. What is this checked exceptions? We'll see. So in this case, in case of checked exceptions, so here I have not explained you the multi-threading, but I'll be trying to tell you with this. Otherwise, I can take an IO exception. So for example, what is an IO exception is, IO exception is nothing but your checked exception, or you can call that as compile time exception. Why I'm calling that as checked or I'm calling it as checked or compile time exception. For example, you are trying to read something from a file, right? And if the file is not there, so what happens? There is a chance of getting an exception, right? So when you're trying to perform this IO operations, your compiler will forcefully ask you to write try and catch. If you are not writing try and catch, it will show me an error. So for example, in this arithmetic exception, if I don't write try and catch, it will not show me an error. So I'm dividing by 0. I have not written try and catch, right? So I'm directly dividing by 0, right? My compiler is not showing me an error, but I'll be trying to do the same thing with the thread.sleep. So thread is something where we have not discussed multi-threading, but I'll be telling after this, then you get more clarity. So you have a method called thread where you are trying to make that sleep for some time, some part of the code. So I'll remove everything here. So you have a method called thread, and in that method I have a method called sleep. So this is your multi-threading. So sleep will take a millisecond. So I'm giving some 10,000 seconds. So it will be waiting for me for 1 second, right? So for 1 second, your program will be stopped. For example, if I don't write thread.sleep, what happens after sleep method? Directly it will execute, right? But I just want to make some user to wait for some time, right? So in that case, I will be giving.
I know. It's like the weight in the yeah, some like how to say, yeah, some like you know, in the automation script there are something like a wait. It's like a same function, some similar function. Yeah,
Yes.
it will
So
wait
you
some
have,
time. Yeah.
yes. So you have wait, notify. We'll see this. That all concepts that comes under multi-threading. We'll see that, right? So as of now, you assume that there is something like thread.sleep. Right now, this sleep method is something where you will be waiting for some time, right? You have a wait method also. It will also do this.
I got to the point. Yeah.
So here, there is a chance of whenever there is some thread is sleeping, so there is a chance of getting an interrupted exception. If you see, there is a chance of getting an interrupted exception. So this interrupted exception is a checked exception. So when you are writing thread.sleep or when you are trying to read from the file, what you need to do is nothing but you need to handle that exception. It means I need to write try and catch. If I am not writing try and catch, your compiler will not allow me to compile itself. So whenever there is no compiling itself, you cannot run it, right? So you can see there is an error, right? If you are seeing that it has an unhandled exception type, interrupted exception, there is unhandled type. So what you need to do, we'll see what is throws, but what it is trying to do, it is asking you to surround it with try and catch. So writing a try and catch is mandatory when you write some kind of interrupt whenever you are using some thread.sleep or some kind of things. So here is nothing but your compiler is aware of that exception. So there is a chance of here your there is an interrupted exception will also will not come at compile time. It will also come at runtime only. But what happens? Your compiler will warn you. Okay, so there is a chance of getting an exception. So for that, for sure, you need to handle this exception. It means
Okay.
first you need to write a try and catch. Without writing a try and catch, it will not compile. So here, if I should be writing a try and catch.
Basically, when the exception is there is an arrow icon for the exception, and this kind of exception is checked.
Yes.
Right. So
Yes.
so it's similar to the arrow.
No. Error, compile time error. You get a compile time error. So your compiler will not allow you to do that. So then that case of that exceptions is nothing but your checked exceptions. So for example, in before case of arithmetic exception, I divided by 0. So compiler has not asked me to write try and catch. It is not forced me to do that, right? So you can able to compile the code, right? So that you are calling it as unchecked exception. So here we are calling checked because compiler will force you to write and try catch. If you are not writing try and catch, it will not compile itself. So that's the reason I'm calling this as compile time exception or checked exception.
Yeah. I mean the checked one, because for the checked exception, you will see an arrow icon. Like that's my point. But for the unchecked exception, you will not see any arrow icon, right?
Yes.
Yeah, but I mean I understand that checked exception is a type of exception. It's different from arrow, right?
Yes.
Yeah, that's different. But I mean, if I write a code there is an arrow, I will also see like a red cross, right? I mean red cross, I will see it.
Yes. You will see a compile time error.
Yeah. Okay.
So
Okay.
it like your compiler will not allow you to write a code before compiler will not allow you to write the code without writing that actually.
Yes. Okay.
So if I run this, it will be.
But why the question is why this this sleep one is a checked exception? It just depends on the compiler to recognize, right? We cannot define it.
Yes. So whenever the Java people, what they done, they have given some time of exceptions or checked exceptions. Why? Because they felt that these are the exceptions that are going to come really right at runtime, and this kind of exceptions. What they done, they force the developer to write a try and catch. They are forcing the developers to write the try and catch because at runtime there is a chance of getting this exception. So they have done classification like that.
Oh, okay. Like checked.
Java
Like
people.
it's more, how to say, it's very predictable to be happen in future, something like that.
Yes, exactly, man. So
But
there is a
but unchecked exception is like you cannot you cannot protect it. Like
yes. So for
yeah.
example, a null pointer exception, I'll just show you. A null pointer exception, you cannot write try and catch because a null pointer exception can be occurred anywhere, right? So you cannot put a try and catch everywhere. So but here when you write a thread dot sleep, it will write so it is like it will know there is something. I'm making this to wait, this statement to wait for some time. So then what happens?
It's like the compiler will tell you you need to write an exception.
Yes. You need to write that exception. So that is nothing. IO exception. Even for
Shit.
example, whenever you are trying to read something from the file, for example, I have an IO exception. I have a text file, right? So I want to read that from that file. So whenever I just want to read from that file, so I need to handle that. So assume that the file was not there. I'll be someone has deleted that file. So the file was deleted, you cannot read it, right? So there's a chance of getting an exception. So that's the reason they put that under also checked exception. When you do IO operations, input output operation, you need to write a try and catch. Like that they have kept, right? So these are some classifications of your exceptions. Okay. Okay, Mike, just go through this. So you just go through this. We'll see if any doubts. Okay. Okay, Mike, I'm
Yes.
taking off.
Okay. Yeah. Thank you. Yeah. Thank you. Have a good night. We will connect tomorrow.
Okay, you just go through this. If any issues, let me know. Fine.
Okay.
I've shared this examples to you.
Yeah. I let me see. Okay, I got it now. Yeah. Thank you.
Okay. Thank you, Mike. All right.
Bye.